Thank you everyone for joining this webinar. My name is Mark Pillar. I'm the founder of Backendless. And today we'll be talking about designing your database for scalability and really how to work with the databases when you're building mobile and web applications using no-code technologies. My company, Backendless, we provide a platform for building mobile and web applications with or without code. It's completely up to you how you want to use the system. So we definitely have a lot of experience in helping developers to build applications, primarily just by providing the platform that they use to do this. And so now I'll just switch to my presentation that I put together that talks about many of the concepts that I believe are very important. But I really want to get a confirmation if we're good to go or not. So if someone from the organizers could let me know, that would be fantastic, because I don't really hear any audio, and hopefully you guys can hear me. Okay, I think we are good to go. Excellent, thank you. All right, so I will switch to my presentation. Let me share my screen. And here is my PowerPoint. So today's agenda, what are we going to talk about today? So first of all, we will review what it means to have a no-code backend, the kind of things that you should be looking for when you're planning to build an application, or if you're already building for one, what kind of things to look out for and something to keep in mind. We will talk about just the basics of the database design, how to go about approaching this task, because it is an extremely important task, especially not only from the perspective of building an application, but kind of thinking ahead about the things that may become or will become important as your application grows. Frankly, the majority of the applications are built for growth. Very few of them have local use where you know it's going to be on department in the organization and so on. The majority of applications are being built for large scale. We will talk about what it takes from the design perspective to the kind of things that you need to put into the database design that will yield better performance. Like how to get the most from the design of your system, where application just continues to run smoothly when you have 1,000 users, 10,000 users, million users, how to make sure that the application just continues to run smoothly. And I will just go over some of the best practices. Something that I wanted to mention is that as I go on, you may or will have questions. Feel free to put those questions in the chat window, which is something that I need to do is I will just switch back to open the chat window so it is in front of me, and I can see as questions come in. So let me open up the chat panel. All right, I have it now, and I will go back to the presentation. All right, so no-code backend, primarily database is going to be the most important thing, okay? But in addition to the database, there are many other things that really come into the no-code backend. I took these boxes from another presentation that I did where I talked about Backendless, but I believe that these functional areas apply uniformly regardless of the system that you use to build applications without any code or even with code. So database, a large block here. The reason it's big is because I believe it is going to be the most important thing that you could have in the data-driven application. That's why it's going to be big and significant. Of course, all other areas are going to be equally important, and some of them may be even more important than database, depending on what your application does. But from the database perspective, I believe picking the right tool is going to be the most important, really based on how solid the database support is. If you make a mistake there, it may become rather expensive and complex to actually switch to something that works better. So selecting the right tool that has the most scalable and feature-rich database is going to be important. Of course, from the backend perspective, all other boxes that you see here should be present, because in this setup here, I put together all the functional areas that I believe are uniformly applied to a variety of different applications, regardless if you're building a social app or an enterprise app or even a chat application. Many of those functional areas will come into play. It's going to be fairly straightforward. It might be straightforward for me, but I think it should be fairly straightforward for a lot of users to kind of see, if you take, let's say, user management, can you manage your users without any code? Are there enough graphical tools where you can set up the user profile and assign security roles and change their passwords and modify, whether that user is enabled or disabled, or shut down that user, or added user properties? All those things are going to be important. And likewise, for many other areas, like with file storage or push notifications or API services, pay attention to whether you can easily configure those functional areas. Like, for instance, with push notifications, my expectation would be, when I work with a tool, is that I can go in and I can configure what the push notification looks like. I should be able to configure all the visual aspect. Like if I want, additional buttons, like, you get a message, a push notification, and you just want to reply without going into the actual app right from the notification screen. There's going to be a way to do this, and without writing any code, if you're looking for a pure no-code solution. With email marketing, I should be able to define an email template, be able to customize it for each individual user, and then start sending out those emails based on the template, again, without really any code, if you're looking for a no-code solution. So those are going to be the functional areas. And I'm kind of stepping out of the focus on the schema and the database, because we're talking about no-code backend. Again, with everything that you see on the screen, the platform that we provides all of that out of the box. So you get it with pretty much every single pricing plan, including the one that is free. All of that is included, and you can use that. So if you're interested in checking it out, the company name is Backendless, but I will not be doing a whole lot of self-promotion, and that is my promise. So with that, let's move on and take a look at the database specifically. So what are the things that are going to be important database? Let's imagine that you have an idea for an application. You're thinking about, users will be able to do this and that and so on. You may not necessarily think about the database features that you need. The list of things that I put in here are fairly general purpose features that a modern, sophisticated, and general purpose database needs to have, regardless, once again, of the type of application that you're building. So you could be thinking, well, I'm building such and such application, it must be NoSQL database. I believe that thinking is wrong. Whenever you start thinking about specific technological features when you're going from the marketing view of your application, that is absolutely wrong way to think about it. And I'm convinced with that. Of course, you may disagree with me, and that is going to be okay. I'm strictly operating based on the experience that I have building a lot of different apps. So in here, let's just go over this list. Data types. Data types are very important. So what are data types? Whenever you operate with data, you will know that you will have some strings and large texts and integers and decimal values and file references, phone numbers. Those are going to be different data types. The richer the set of the data types that you have, the easier it will be for you to capture the data that the application is working with, okay? And that's pretty much it, right? So you will be able to quickly judge if the database has enough data types that would exist in your application, simply just by looking at the data types it supports, okay? Support for relations. This is going to be something that, a lot of people will have different opinions. In my opinion, support for relations is extremely important, simply because we live in the relational world, okay? When you look at any given problem that exists in this real world, okay, very seldom there will be an entity that exists just by itself. Especially if we're talking about users and the things that the users can do. And then in most of the applications that you will be building or you are building, it is always something about users. Users can place orders. Users can, chat with other users. Users post comments in the blogs and, in social media and so on. So all those entities, comments and users and orders and food that they order or Uber rides that they take, they're all related to each other. What it means that when the data sits in the database, those relationships need to be maintained, okay? And if the database supports those relationships in a way where it's easy to work with them, where, you have a user and you can load all the user orders, okay? That's going to be basically relationship retrieval. If you have support for that, it becomes important, and it will become easier for you to actually model your data and use the database that provides support for those relations. Someone could say, well, relations in the database, it means it's relational database. Yes, and there is really nothing wrong with relational databases. Of course, there are use cases when non-relational databases are applicable, and they can coexist. But the fact that NoSQL is something that is modern and cool, it doesn't mean that NoSQL replaces relational data. I say use both where it makes sense. Okay, so if you really are excited about NoSQL and so on, fantastic. However, use it where it makes sense. It doesn't mean that NoSQL needs to be completely replacing everything that SQL does. By the way, when it comes to the database support for SQL, like as far as the actual querying, I think it's really relevant. For some people, it's going to be easier. For other people, it will not be so much. I always look for a way where I can express queries in the most possible and natural way. What that means, though, is the bullet number 3, rich query support, becomes important, where you can express the kind of queries that your application will do in the most natural way. Okay, there are different strategies and there are different implementations that exist out there. Some databases provide a way to query data in a very limited format, like, load everything where, city equals New York. It just gets all the countries, or like gets all the, restaurants in New York and so on. In other ways, you may need more robust and more sophisticated way to load data, where you just want to load, let's say, talking about restaurants, like, load all the restaurants in the city of New York where the cuisine is French and where the average rating is above 4, right? That becomes a more complex query. So if you know that your application is going to be doing things like this, you will want to validate that the database that you're choosing for your application will be able to support this kind of thing. Data size limitations. There are solutions out there that will say, okay, well, you can store as much data as you want. In fact, our solution does say that you can store as much data as you want. There are other solutions that will say, that may not necessarily say it, but they will have limitations, okay? So look for those. Some databases can scale infinitely. Some databases will just have a hard limit. For example, and I'm not saying that it's going to be a bad solution, but it's something that should be well known. When you build applications with Airtable, you will be limited by 50,000 records in the database. That's it. The limit is hard set. So if you're planning to scale beyond 50,000 users, beyond 50,000 orders, beyond 50,000 comments in the blog posts, you will be struggling, because you will just need to figure out a way how to go over that limit, or pay a lot of extra money if it is even possible. So those are the kind of things you need to keep in mind that may not be entirely obvious just by looking at the marketing literature, okay? Non-relational data support is something that I touched. It's basically being able to support and store data that is not very well defined. JSON seems to be the standard, and it's great, but use it only where it makes sense. It's not a solution for everything, okay? In fact, whenever you use non-relational data to capture information about entities that are purely relational, you are getting into, you're putting yourself in the corner, okay? It's going to be much harder to manage that kind of data if that's the approach that you have taken, right? Transactional support, very important, for the reason that by definition, A transaction is something that whenever you run it in a database, if something fails, it does the rollback, okay? It saves a ton of time. It saves your database integrity. It saves essentially both maintenance, from the maintenance perspective, and from the implementation perspective. Because if you don't use transactions and something failed and you have to go and your support has to go into the database and do the manual cleanup, you'll be wasting a lot of time and money doing that. Versus if you run it transactionally, and if something fails and it rolls back the whole thing automatically, beautiful. That's exactly the kind of thing you need to be looking for. Management functions are going to be primarily UI driven, the kind of things that you can do to kind of, operate on your database, to establish indexes, to establish constraints, to establish security permissions, and so on. But quite often it also becomes important where you can do the same things using APIs. And then the flexibility of the APIs, both from the being able to work with your data as well as to work with your database, becomes very, very important. So I'm sorry for kind of getting stuck on this slide for so long, but all of those things I believe are extremely important, and quite often we see that they're being overlooked. So that's why I wanted to spend more time kind of thinking and just going through these things. All right, let's move on. Application design. So there are two primary philosophies that exist on the market today. Not so much today, it's been like this for as long as UIs existed. One of them, which is what I prefer and recommend, and that's what we recommend when people come to us with projects, it is the user experience first philosophy. And that philosophy and the mindset essentially means that before you start going into the database design and thinking about, queries and so on, identify UI and user experience first. Figure out what users will see on the screens. Figure out how they will interact with data. Figure out how different applications in the same suite of apps will work together. For example, let's take the same, let's say Uber or Airbnb. You have UI and user experience of the person who goes out to make a booking. You have UI and application of the person that rents out a property in Airbnb. You have a separate UI that the staff of Airbnb goes in to see what's going on. All of those apps really work with the same set of data, but they have different perspective. So capturing that information in the form of some kind of UI first, before you do anything else, is going to be extremely important. And I will tell you why. By the way, capturing it in the form of the UI does not mean making it pixel perfect design. It doesn't mean that you have to get a designer, kind of, flush it all out. It helps, but it's not important. What's most important is actually capturing in some sort of where you can kind of understand what the users will be seeing, how they will be experiencing your application. Making it pretty is also important, but I believe it is secondary. So capturing it in the form of mock-ups or storyboards, or even if it is just drawings on the whiteboard or paper, but do that first. Identify all the areas that users experience. That will define the information flow. Like, this is how an order is created, and this is how the orders can be seen by some other party. And this is how the order is being procured, let's say, to a driver to pick up that order and deliver it to the consumer. Once you have that UI captured, okay, that's going to be a good point where you move on to actually getting closer to the database design. And then I will walk you through a primitive use case here and on the next slide. But by looking at your screens, you'll be able to identify the actual entities and the concepts that exist in your application. And you'll be able to start breaking down those entities into individual properties that exist in there. And that will really map one-to-one to the database design, okay? You will be able to see the relationships, and then those relationships could translate to the relationships in the database. When you look at any given screen, think about, okay, well, if these are my entities, if this is how that will be stored in the database, what kind of queries you will need to run. Okay, do you need to, break the data into individual pages and implement paging, or load all the data at once? If you get to the point where you need to load all the data at once, think, will that data continually grow over time, or it's going to be a finite set? If the data is going to be growing and you need to load all the data at once, problem. Stop and rethink about it, because if you're designing your application where you're going to be loading all the data at once, and that data set is growing, your application will start getting slower and slower, just because loading more data will take more time. Okay, let's walk through this process. And what I did is I just Googled Uber Eats clone and picked the first link, and there are some screenshots in there. So, and if you're interested, I'll find the link and put it in the chat. Just let me know. But anyway, so just by looking at these three screens, okay, what do we see? On the first one, we see cuisines. Okay, well, cuisine here, it's going to be a concept. Okay, because at the very minimum, a cuisine has the name and it has an image. Okay, as you can see, burgers, sushi, bar food, breakfast, and so on. So those are different categories, and they can be represented as a separate entity, cuisine. For any given cuisine, we do have a list of individual dishes. Okay, and as you can see here, we have this Benjamin Cooper Boucher, or I'm not sure if I pronounced it correctly, but anyway, so those are individual, I think, locations, right? They're actually not dishes; these are locations, and it's something that I missed in the description. So, and then for individual location, there are dishes that exist, and as you can see, that the third screen, those are individual dishes. Okay, and there is also at the very top, there is a shopping cart and the map, those little icons that exist. So those are the entities that we can quickly identify just by looking at these screens. Okay, next, if we take a look at the individual screens that look at the dishes. So here, for the place called Boucher, we have, these are different dishes that they serve. And then the second screen is represents the details of a given dish. So if we take a look at the dish entity detail, here we have a title, or the name, there is a description, there is price, there is main picture, and there is picture gallery, right? So this is how we break down that specific dish. Okay, now, just with these two slides, and we have 5 screens, if we were to translate everything that we have captured into the database design model, we could have something like this. By the way, this is not entirely correct, as I just saw that I missed the concept of location. Okay, so this schema would need to be expanded to have location. But in here, what we already have is we have a relationship from users to a shopping cart. It is one-to-one, so a single user can have one shopping cart. And the shopping cart has I didn't do it right. So the shopping cart has the relationship to dish, and it shows that relationship is one-to-one, which is wrong. It actually needs to be one-to-many. A single shopping cart can have multiple dishes. And then a dish has a one-to-many relationship to cuisine. And then, I'm sorry, my mouse pointer here is not working because I'm on the full screen, but if you look at, for example, dish block, which is essentially going to be the dish table, at the very bottom it says cuisine, and then on the right it says rel, which means relation, 1:n, which means one-to-many. So a single dish could be in multiple cuisines. For example, it could be, could be a burger, and then another category would be lunch. So this way, kind of, 2 categories would contain that particular dish. So this is the kind of iterative process that we normally follow, and that's what we recommend. Just going over your screens, identify entities, capture in the schema, go back, review, and just start thinking about the queries, think about how the data is going to be retrieved. And with our tool, you can start creating these visual diagrams that display all your tables, so you can see the whole big picture at once. All right. Now, that's what I wanted to talk about as far as the actual designing your schema. So let's start getting down into individual things that will make your application run faster. By the way, if there are any questions, please use the chat pod and add them in there. I'm not sure if mine's going to get stuck here, so it's not automatically scrolling. So if there are any questions, please let me know somehow. And I'm talking to other panelists on this webinar. Anyway, things that will make your application run faster or slow. One of them is the really controlling the number of columns that you have in the database table. Okay. Sometimes it could be very tempting to expand your table and put more columns in there, where a single record, let's say take a look at the user record, could have almost everything and anything related to that user. Okay. The rule of thumb that you should follow is that, and it's convenient, you put everything into that user record, you make an API call, you retrieve that user, and you have all the data in there. Okay. It's convenient, but convenience does not always produce speed, because if you have a very rich and elaborate user record, it will take longer to load all that data for a single user versus breaking it down into smaller tables that are in using relations that will yield better performance. Keep in mind that your goal is to build applications that will have millions of users. If you have millions of users, and if your user record consists of 100+ columns, you are by design getting yourself into the situation where retrieval user record will be getting slower and slower, simply because they just have persistence works. Okay, so try to keep the column count to be as small as possible, but not smaller. Okay, so let me demonstrate an example. So here's a schema from one of the actual applications that we have, and in here, as you can see, there's a bunch of different relations. I just took a screenshot of just a portion of it. Okay, and then in this case, the application in this case, what the developers did is they added a bunch of different things. They are using relations, and as you can see, there is a bunch of columns that are marked as REL. Okay, however, many other things that exist here in this users table, in my mind, not necessarily need to be in here. For example, things such as these total comments, total connections average, things that exist at the top, I believe are misplaced. Okay, there's really no reason to keep it in here. Of course, developer may have their own reason. Okay, but I believe schemas like this really should be simplified. Okay, let's see. There are a couple of questions that we have here. All right, the question reads like this: in traditional relational database schemas, dish would have a foreign key to card. In your example and other low code I have seen, there is a $1:n, which is one-to-many collection schema, like you have with card to dish. Is there a reason for that? Would it be wrong to have dish with one-to-one relation to card instead of card with one-to-many relation to dish? Great question. Let me go back to that schema right here and talk about this. So, in fact, rather than card to dish, let's talk about dish and cuisine. Okay, so in here, the relationship goes from the dish table to the cuisine table. And the relationship here is that a single dish may have will have one or more cuisines. Okay, or it could be in one or more cuisines. So the question here is, what would be the proper placement of that relationship column that connects cuisine and dish? Would it make sense to put it in a dish, or would it make sense to put it in cuisine? From the backendless perspective, it doesn't really matter. Okay, placing it in dish or placing it in cuisine you will be able to retrieve data one way or the other. The reason I placed that relationship into the dish table is because new dishes will be created more frequently than new cuisines. Okay, and as a result, I'm envisioning that when I create a new dish in the system, like we're signing up a new restaurant and they give us the menu and we have to populate it with different dishes. Since dishes are going to be created more frequently, when I am putting a dish into the database, I'd rather link that dish to an existing cuisine rather than updating a cuisine every time a new dish is created. Okay, so I have a set of those cuisines, and then I'm adding a dish, and I'm just going to relate it to an existing cuisine. So in my mind, that was the simpler thing to do, is to update an object that is just being created with something that already exists in there. Okay, so it really just becomes kind of a management task. Whenever you need to relate two objects together, there is going to be an update of one or the other. And I decided to update the one that I'm actually creating more frequently, which is dish. To answer your question, where would it make sense to put the relationship? I think that was the question. Let me actually reread it. Is there a reason would it be wrong to have dish? So I guess you're really asking, where would it make sense to put this relationship? It really depends. It really depends. What entity contains other entity. Okay, so traditionally relationship, just from the UML days, represents the has a relationship. So if entity A has a relationship to an entity B, then that relationship really represents has relationship, like A has B. And in this case, whether dish has a cuisine or cuisine has dish can go either way. In some cases, it will be rather obvious, where that relationship needs to be. Okay, so hopefully I answered your question. All right, another question from chat. I see the picture gallery is a JSON. Is this better than an image data type with a one-to-many relationship from the dish? Okay, if the database supports image data, then it really becomes a question of whether you would want to store images in the database. And then you will see it further down in this presentation, I try to avoid as much as possible storing binary files, such as images, in the database. Okay, and with Backendless, there is a file storage that you can use for storing files, and you can link your database records with those files. So if I can put a file into file storage and link my database record with that file, that's what I will do. Okay, the reason, and we have picture gallery as JSON, the reason it is like this is because if I want to have multiple files represented through a single property in my database, okay, JSON is going to be the best data type that would describe this, because here I could have a JSON array of strings where each string is essentially a URL to that file. Okay, so this way I can retrieve the data and I have that array of URLs and I can easily render it on the screen. Okay, so JSON seems to be the best data type that fits that requirement. And there are some things that we're doing, like for instance, we are going to be very soon introducing a data type which is image gallery, which is essentially going to be the same JSON that's just going to be represented as image gallery. But when you work with it, you will still be getting a collection of URLs. Okay, so that's the reason that I use JSON rather than image data that sits in the database. To me, JSON provides a better development experience to store a collection of URLs. Okay, all right, let's move on, and I will come back to questions. All right, so we talked about this, and as you can see, there is just visually, it looks like a lot. So whenever it looks like a lot, review it. Just think critically about every single property, whether it really belongs here or it could sit somewhere else. All right, next, indexing. So indexing is a function of the database, if your database supports it, that essentially you can identify an individual column and ask the database to do its magic, where it basically says that whenever you are querying data by that column, it will have all those special things inside a database to actually find that record quickly, and which is an index, okay? So for instance, if I have, let's say, a database of users, and I have millions of users, and for me, it is important to find users of certain status, or of users certain name, or whatever makes sense, then I would index the columns that I searched the most, that table. I would essentially turn on indexes for those columns. And that will significantly speed up your database. The benefit of that performance improvement comes into play only at a certain point, because if you have a database with just a couple of thousand records, adding indexing may have detrimental effect. It may not actually yield any better performance, okay? And you can play with it. Just turn on index, run a query or a couple of queries just to see if your queries start running faster. Sometimes it's going to be about the same. Sometimes it could be actually slower if your database is small. If your database is large, more than likely, and you will see a fairly significant performance improvement, okay? All right, next, using relations versus data in columns, and that's a very common design decision that you would be making in your applications. For example, let's going back to our dish and cuisine. So here on the left, you see that there are two tables, dish and cuisine, and the dish defines a column called cuisine, which is a one-to-many relation, okay? Which means that whenever I need to load all the dishes for a particular cuisine, let's say I want to find all the dishes that are, French cuisine or breakfast or burgers or whatever. Breakfast, not so much a cuisine, but you get the idea. In here, I get the cuisine object and I say, well, load all the related objects. Actually, it's going to be the other way. I basically load all the dishes where the cuisine dot name equals, breakfast. So that's the relation retrieval. An alternative to that approach would be a schema that is on the right, where the cuisine is just a string. Okay, so this way there is no relation, and I can load all the dishes where the cuisine equals breakfast or French or Italian or whatever. Okay, which is better? It depends. There is really no golden rule to say which one is better. Okay, and it depends on several factors. It really depends if, in this case, the cuisine needs to be an entity that has its own representation in the UI. And in the UIs that I have demonstrated, it does, because in there, as you remember, there is a name of that, because there is a separate screen. There's a name and there's a picture. And it really makes sense to kind of use the relationship in the traditional sense. If I go with an approach that is on the right, where the cuisine is just a string, then it becomes a little bit harder to maintain, not so much harder, but more work to maintain the integrity. For instance, if I have dishes where the cuisine is Italian, I need to make sure that I have a definition somewhere of an Italian cuisine with a picture that represents this cuisine and so on. So you end up with some kind of disconnect where you can have data where you identify those strings, and then those strings need to be present somewhere else. So is there a trade-off? Which one's going to be faster? In most cases, the one that is on the right is going to be faster. But you will see that it is faster only when you have very, very large data set. If we're talking about the application that we had, where we have, a dozen or so different cuisines or food categories, and you could have, thousands of different dishes, having it done as shown on the right versus on the left will not make any difference at all. You could see a difference of a couple of milliseconds. To the actual user, absolutely no difference. So go with whatever makes your application go faster, okay? Go with whatever make your application development go faster. Makes it easier to manage your data. Makes it easier to expand the kind of things that you want to do as far as the features. Okay, here, if there's a separate table for cuisine, you can start doing more analytics, which cuisine people are ordering more frequently, which one is less popular, and so on. So those are the kind of things to keep in mind. All right, next. All right, another thing that happens quite frequently in database design, using integers versus strings or relations to optimize searches. So here in this example, this is yet another application that is real and is in database. The screenshot of the user profile table on the right. As you can see, there are multiple properties that are integers, such as education level, ethnicity, and this is, by the way, a dating app. So there is a user profile that identifies that kind of profile. And as you can see, the data types for many of these properties are integers. Like hair color is integer, ethnicity, height, and so on, or marital status. Application is built for growth, to support millions of users, millions of profiles. And in a dating application, being able to quickly show all the profiles that match your search or your interest is going to be extremely important, because you just want to see it quickly. Okay, so using integers here will yield that result. It will provide faster searches, just because for the database to find matches that are based on numbers, it will work significantly faster than finding those matches that are based on relations or strings. Okay, and in the database design, let's say if we have hair color, there's another table which is profile hair color that defines different hair colors. Okay, and then the integer here that you see on the right is going to be an integer that represents a specific ID that represents that particular hair color. Okay, and using this approach, you basically have different tables that identify different marital statuses and education level and ethnicities and so on. And then in your profile, you just have those numbers. As a result, this specific database design yields better performance once you start hitting larger data sets. Okay. All right, let's move on. And this is going to just combining all other things into a single slide. And I think we're almost at the very end of my presentation as far as the slides are concerned. We'll definitely be spending time with questions and so on. So, and I did talk about using JSON for flexible, less defined data at the beginning of my presentation. So I just want to repeat that. There will be scenarios when you will be dealing with data that does not uniformly apply to all users or all entities, where, for some entities you could have this and for some entities you could have that, like insurance policies. Okay, that could be a good example. Some insurance policies have certain specific fields that apply to everyone, but there could be exclusions or special conditions or things that just don't apply to everyone. Capturing those as JSON and attaching it to the policy in the database schema would make sense. Similar for users, if you have certain things that do not apply to all users and are special kind of properties that apply to some, putting it in the JSON would make sense. Okay. Files in the database, we talked about that when we talked about creating gallery. I personally do not find a good reason of storing files in the database, period. Because first of all, if you want to search in files, you can search in files outside of the database. If you want to retrieve files, retrieving files from the file system is always going to be way faster than retrieving a file from the database. Okay, so something needs to be in the database, I believe, is something that needs to be searchable. Okay, if you look for a simple way to put it in the database, retrieve from the database, and if it is the file, I think those operations that apply strictly to file system are just as simple, if not simpler. Paging. So paging is the key to solving the problem with lots of data. Okay, in Backendless, paging is baked into our API. You cannot get all the records with a single call from a data table, for the reason that the majority of applications that are running in Backendless, there are thousands, if not millions, of records in the table. If we were to create an API that retrieves everything, retrieves 100,000 orders or millions of users? Well, first of all, not a single UI can consume million entities, or a single user can consume millions of entities just on the screen. You cannot even fit it on the screen, okay? Therefore, as tempting as it is to say, oh, I just want to get it all, think about it. You may not always need to get all the objects. If you want to run some aggregate functions, like calculate counts, and sums, and averages, and so on, the database should provide those functions. You do not need to calculate it on your own. Sometimes you do, and in this case, there's business logic where you can load as much data as you need to do the number crunching. But from the UI perspective, there are very few reasons why you need to have everything on a single screen. We see that question quite often in our support forum. How do I load all the data? And once you start kind of prodding in and just figuring out what is it that you need to do, there are really no meaningful reason to do it all and just to load it all and put it in the screen. So paging solves a lot of problems, okay? And it could be done in a way where it's a long scroll. Long scroll is paging. Whenever you scroll through Instagram or Facebook or Twitter or whatever, paging is always there. You get to the bottom of the screen and you need to get, where it's like you're 10% from the bottom of, the screen, they will preload more data, and that's paging. It doesn't necessarily mean that you need to have page 1, 2, and 3, and so on in the traditional sense, but it's extremely important. Caching. Whenever you deal with data that doesn't change frequently, put it in the cache. And then in your logic, create an API service that checks in the cache first. If it is not there, goes in the database, puts in the cache, returns back to the user, okay? But it is for the data that doesn't change frequently. Of course, once the data changes, invalidate the cache. But having the basic principle of applying cache as frequently as you can for as many things as you need will yield better performance, okay? If you put it in the design of your application first, you will benefit from it greatly later. Because let's face it, everyone starts with an application that doesn't have a lot of record, doesn't have a lot of users. Therefore, the benefit of caching is going to be very small initially. And yes, you can refactor your application to introduce caching if you have a dedicated entry point for your API calls. If you're hitting the database directly, yeah, you're going to be retrieving everything from the database. But if you're hitting your API service, that includes some business logic of putting data in the cache, then you have a good strategy to expand the kind of things that API service does. Finally, transactions instead of individual operations. So you could basically save data and then do a query and extract, the first object from the query and then establish the relation. Just, write a script that does all those things. If something fails, then whatever you have written or updated needs to be reverted back. All of that can be done almost automatically if you use transactions. And that assumes that the database that you chose for your application supports transactions. So here, the rule is very simple. If you're doing multiple things with your database, as far as saving something, updating, and then doing retrieval and updating something else and establishing a relation, put it in the transaction. It will save hours and hours of time of debugging, and it will just create, it's going to be a better application. Simple as that. All right, I believe we are at the very end of my presentation. So we have some time left for questions. I'm going to go through the questions that I have here. Let me just stop the screen share, and I will go to the questions that we have so far. All right, the question regarding reducing number of columns. Would it be better to have fewer columns and have more tables and connect relevant tables by relations? Yes, it would be better. I believe it would be better, especially if you have minimal set of columns that represent your entity. And whenever you work with this entity, it gives you the sufficient amount of data to represent it on the screen, or do some additional calculations and apply the logic. Yes, reduce the number of columns. It needs to be as small as possible, but not smaller. And if you have relations, you're not going to be penalized significantly by retrieving related data. In fact, the APIs that we provide give you an ability, if you have entity A and it has a related entity B, you can load both of them together using the APIs. You can load data for B later if you already have entity A. So those things are possible. But I believe going for cleaner database design is just a better strategy overall. Would direct variables slow down performance more, or would relations slow down performance more? I believe relations will not slow down performance. I believe loading fewer data will result in your UI application running faster. Because when you load a lot of data and a lot of relational data, all the processing that needs to occur on the UI side with all of the relational data will slow down your application. If you think about, just any given screen, we reviewed some of the Uber Eats clone screens and so on. In most of the mobile applications and even web applications in more recent times, like more modern web applications, individual screens focus on specific tasks, and they are not very elaborate. Like keeping the user focused on the fewer tasks as possible on any given screen just yields better user experience, because user does not need to think, which is very important. You don't want to make the user think. So focusing on some specific tasks, and they're limited on any given screen, really means that you need to have only a specific subset of data. As a result, loading only that subset of data without a whole lot of elaborate relations will be better user experience in the end. All right, let's move on to the next question. I'm not a software engineer, so lots of new info. I'm working on a social app that automatically removes data from chats and groups, so it's time-bound. The goal of keeping the database lean, fast, and safe. Thoughts? First of all, congratulations, and it's fantastic that you're working on something that sounds that complex, and if you're not a software engineer and making progress, amazing. I love that. As far as just the approach to this, I think everything that I have said would be applicable. User experience first, figure out what is it the user will see, start identifying concepts, start breaking them down into individual steps that your application would have to go through as far as retrieving data and where things will occur and where it will be removing data from chats and so on. There is definitely going to be a fair amount of algorithmic processing with what you described, but I think just the overall process is going to be pretty much standard here, like UX, database schema, business logic, data flow, think queries, think where individual things will have to happen. All right, question coming from the Uber Eats example. In the right example, you need to repeat a lot of data per record, for example, cuisine pictures. So the left one is better to reduce no value. So yeah, on the right, we were basically putting the cuisine right into the table, and on the left, we had two tables. So yes, the left one's going to be more optimized because there's going to be less repetition. Absolutely. All right, let's see if there are any other. Okay, so there's one more question real quick. I'm a new developer and I started using Backendless as my database for a small Flutter app. Are there any tips that you can give me so that I can easily use Backendless and find the features I want to use? Whether you use Flutter or React or Android or iOS, or you do it with NoCode, such as UI Builder or any other NoCode tool, Backendless, especially if you use external tools, Backendless will come in as the backend. And you would need to come up with your database schema. You would need to figure out where the business logic goes. You will need to think about, how security will work, whether you will have users in different roles and what restrictions will be applicable to those roles. Again, everything that I have gone over in this presentation, where you define your user experience, then you start identifying entities and concepts, start breaking down those entities into individual properties and mapping them to the database schema. that remains. Whether you build your UI with Adalo or AppGyver or Bubble or whatever, the process of identifying your entities and breaking them down into properties and creating relationships and capturing the database schema, that process remains to be uniform. It's completely agnostic to the actual technology that you use. Did I miss anything? I think that's all the questions that I have. Let me check there's a Q&A section, maybe there's something there. Are there a question if we offer consulting for the database design? Yes, we do. Just send an email if you would like us to look into it and provide you with a quote to sales@backendless.com. We'll be happy to assist you. Let's see if there are any other questions. I think these are all the questions. Cool. Guys, it's been an absolute pleasure to present to you. Thank you for all the questions. If you have any other ones, I'll hang around for a couple more minutes. But I hope you found this useful. And if you need to reach out and ask for some more questions, you're welcome to visit our support forum, support.backendless.com. Hit me on Twitter or LinkedIn. It's very easy to find on Twitter at @MidnightCoder or @Backendless. You'll be able to find me on LinkedIn. But thanks again, and hope you enjoyed it.